Okay, let's now look at this question. It says that a heavy beam is resting on two supports. So the two support is on the left, which is number 1, and there's a support which is on the right, which is number 2. Okay, there are three forces acting on it, which is F1, F2, and F3 at the bottom. Okay, the keyword which is very important is equilibrium. Equilibrium means that this beam is totally horizontal. Okay, yeah. This is the meaning of equilibrium. It isn't lopsided. So which of the statement is correct? Okay, let's analyze one by one. Okay, look at option A. All the forces are equal in value. Okay, in this case, it's not easy to determine because it's just saying that the upward forces F1 and F2. Okay, it's just saying that F1 because it's in balance, so F1 plus F2, which is the upward forces, is equal to F3. So this is what we can derive from this diagram. So the forces supporting the beam is equal to the weight of the beam, which is F1 plus F2 is equal to F3. So all forces are equal in value is not possible because if I say that F2 is 2, then F3 cannot be 2, correct? Because there's another F1 here. So this is not possible. So the option A, equal in value, is not possible. Okay, then we move on to option B. The forces are in one direction and the turning effects are in the opposite direction. In this case, you look carefully, F1 and F2 is acting up, F3 is acting down. So you say that all the forces are in one direction. This is not true. So B is also up because two forces are acting up and one force is acting down. Okay, then we move on to option C. The resultant force is 0 and the resultant turning effect is 0. Okay, this is one of the possible answers because resultant force is talking about objects that is in stationary or is even moving at constant speed. So in this case, because the beam is stationary and it's not moving, this is a possibility. It says that resultant turning effect is 0. It's saying that because this is in a state of equilibrium, in this case, clockwise moments will be equal to your anti-clockwise moments, and so this is a possible answer, which is giving you that your resultant turning effect is 0. So this is possible. So answer is C. Let us now look at option D and see why option D is wrong. Total upward force is twice the total downward force. Okay, in this case, it cannot be twice because the total downward force, in this case is F3, is equal to the sum of F1 and F2. So it cannot be twice the total force, which is not what we can confirm in this diagram. So answer is C.